All right, so 2.8 goes over inverses of functions. With your inverses of functions, the only thing that you are really focusing on is the fact that your domain for your one function becomes your range for your inverse. So your x and your y values are literally just switching when you're dealing with these inverses of these functions. So if we look here, it tells us that the domain of our inverse is equal to the range of our original, and the range of our inverse is equal to the domain of our original. For our first example, we're going to be finding the inverses from these given ordered pairs. You got to think, with this, it tells us if f of 1 is equal to 5, f of 3 is equal to 7, and f of 8 is equal to negative 10, find the inverse of f of 5, the inverse of f of 7, and the inverse of f of negative 10. So with this, you got to think, these ordered pairs that they're giving you from your first section here, so with these functions, you're going to be 1, 5, 3, 7, and 8, negative 10. So it tells you that when f of 1, you have 5. For f of 3, you get 7. And for f of 8, you get negative 10. So if we're looking at the inverses of these, we're just switching those x and y values. So to find the inverse of f of 5, that would give us the x value from the original, which is 1. The inverse of f of 7 would be the x value when y is 7 from the original, so that's 3. The inverse of negative 10 is the x value from the original, which would be 8. We can also find the inverses of these functions algebraically. With these algebraic, or the algebraic way of finding these inverses, we are just switching the f of x to be y, then switching x and y, and resolving the equation for y and writing our answer as f to the negative 1 of x is equal to. So, step 1, change f of x to be y. So this becomes y is equal to 3x minus 2. Step 2, switch x and y. So this becomes x is equal to 3y minus 2. Step 3, solve for y. So we're going to undo the addition or subtraction first. So we'll add the 2 to each side. This gives us x plus 2 is equal to 3y. Then we divide each side by that 3 to get y by itself. And we get that y is equal to x plus 2 over 3. Last step, rewrite the equation as f to the negative 1 of x is equal to. So that y becomes f to the negative 1 of x, keep everything else, is equal to x plus 2 all over 3. For some other examples, if we look at example 1 here, we have f of x is equal to 2 times x plus 7 squared minus 3. So same exact thing. First thing, change the f of x to be y. So this is going to give us y is equal to 2 times x plus 7 squared minus 3. Next step, switch x and y. So this becomes x is equal to 2 times y plus 7 squared minus 3. Next, solve for y. So we're going to move the 3 over by adding it to both sides first. This gives us 2 times y plus 7 squared is equal to x plus 3. From here, we're going to divide each side by that 2. So we have y plus 7 squared is equal to x plus 3 over 2. From here, we want to get rid of that exponent of that 2, so we're going to take the square root of both sides. That cancels out the power and the radical on the left side. So we just have y plus 7 is equal to the square root of x plus 3 all over 2. From here, we're going to subtract the 7 from each side. So this leaves us with y is equal to the square root of x plus 3 over 2 minus 7. Now, last thing here, rewrite this as f to the negative 1 of x. So this becomes f to the negative 1 of x is equal to the square root of x plus 3 over 2 minus 7. For example 2, we have f of x is equal to x squared plus 4. So again, we're going to change the f of x to be y. So y is equal to x squared plus 4. We switch x and y, so this becomes x is equal to y squared plus 4. Now we solve for y. So we subtract the 4 from each side. We get y squared is equal to x minus 4. Then we take the square root of both sides to get y, not y squared, and get y is equal to the square root of x minus 4. Now, we're not writing y is equal to, we want to represent this as the inverse. So we're going to have f to the negative 1 of x is equal to the square root of x minus 4. For example 3, we are given f of x is equal to negative 5x squared plus 3. So this f of x is turning into y is equal to negative 5x squared plus 3. Now we're going to switch x and y, so x is equal to negative 5y squared plus 3. We subtract the 3 from each side. We get negative 5y squared is equal to x minus 3. We divide each side by that negative 5. When I divide each side by that negative 5, that negative cannot stay in the denominator, or at least I don't want it in the denominator. So I'm going to change the sign on every single term here. So that negative 5 becomes a positive 5, the negative 3 becomes a positive 3, and the x becomes negative. So we have y squared is equal to negative x plus 3 over 5. From here, I just take the square root of both sides. So y is equal to the square root of negative x plus 3 all over 5. And then I just rewrite this as f to the negative 1 of x instead of y is equal to. So f to the negative 1 of x is equal to the square root of negative x plus 3 all over 5. For example 4, we have f of x is equal to 5 minus 3x over 2. So again, we're going to change the f of x to be y. So y is equal to 5 minus 3x over 2. We want to switch x and y, so this can become x is equal to 5 minus 3y over 2. I'm going to get rid of that fraction, multiply each side by the 2. So these cancel. We have 2x is equal to 5 minus 3y. I'm getting the y by itself, so we're going to subtract the 5 from each side. We have negative 3y is equal to 2x minus 5. And then we're going to divide each side by that negative 3. Again, I don't care for the negative to be in the denominator, so I'm going to change the sign on each of those terms at the same time. So I have y is equal to negative 2x plus 5 all over 3. I rewrite this as f to the negative 1 of x to represent this as the inverse. And I have f to the negative 1 of x is equal to negative 2x plus 5 over 3. The only other part of this lesson is dealing with graphing these inverses. When we graph these inverses, it's a little bit easier to see it from here. Let's just say that your f of x, if you're looking at these two graphs, is the one, like we're looking at figure 10. I'm looking at the one on the right hand side. Your f of x is that blue line. If you're graphing the inverse of it, it literally is reflecting what you already have. So it's mirroring, they're mirroring each other. So you should be able to cut that right down the middle and fold it to where the two lines mirror one another, so they would overlap each other. So again, if you look back at figure 9, you'll realize that if you have your first ordered pair that's a comma b, you're literally just switching x and y to where it's b comma a to get the point from your inverse.